Hi, today we'll be discussing 3K insights that I discovered while exploring electricity maps. It's a data visualization tool for showing carbon intensity and the different sources of energy production uh, in many countries in the world. So the first key insight that I discovered was that the time of day can greatly impact how carbon intensive energy production is. First, so I saw that during the day, you have lots of solar power, which is relatively clean, so it keeps California's carbon intensity at a reasonable value. But then at night, 6 to midnight, when people are still out, which so the demand is still there, solar power can't help anymore. So California has to tap into its natural gas capacity, which has far higher carbon intensity, 500 versus 26. So this nearly doubles the state's carbon intensity at nighttime. So this tells us that if both consumers and businesses were to limit their energy intensive activities during nighttime, for the case of California, they would greatly help minimize the state's carbon intensity, overall carbon intensity, simply because of the limitations of renewable energy sources in this region, um, and in similar regions where solar power is the key renewable source. Another key insight that I discovered was that just because a country has more renewable energy capacity, more of its energy being renewable, doesn't always mean it's going to be uh, less carbon intensive. For example, Germany has 60% of energy being renewable in 2023. Netherlands had it at 44%. However, Germany's carbon intensity is about 20% higher. This is because Germany's two biggest sources are wind and coal, and then for the Netherlands it's solar and natural gas. So when Germany's solar power starts to, for example, dwindle at like nighttime, this means that coal has to pick up the slack, and coal is far worse at um being low carbon than, for example, natural gas. So natural gas has a carbon intensity of 524. Coal is nearly 63% higher at 859. So this tells us even when our to minimize carbon intensity, even the backup non-renewable source of energy we use should be the cleanest option available. Otherwise, all the effort you put into being low carbon might just go out the window if your backup power is as dirty as coal, which is the dirtiest non-renewable source. And the final key insight that I discovered was that free trade and uh, free trade and imports and exports of energy can help minimize carbon intensity at different times of the day. For example, when during like the European daytime, when Spain has abundant solar power, you can see it's very low carbon, and the carbon intensity of the country is quite low, like globally. However, when the solar power dwindles at night, you can see that it almost doubles the carbon intensity of Spain. However, it would be far worse if they weren't able to import this nuclear power that France has in abundance, mainly because you can see the carbon intensity of this specific export is about 35 grams of CO2 per kilowatt hour. However, the natural gas that Spain has a lot of capacity in, which would have to kick in if this export didn't exist, is far worse in terms of carbon intensity, 520 versus 35. So this tells us that free trade, and specifically the import and export of renewable energy, energy from nearby neighbors that have lots of spare renewable energy just lying around, can greatly help reduce export carbon intensity for uh, any country that's lucky enough to have these kinds of neighbors. Thank you. That would be all.